This problem will test your understanding of radicals, exponents, inequalities, and floors. Feel free to give it a shot and keep watching to see the solution. Okay, so here's the solution. So n is a positive integer, which means that this would have to be at least 1. If this is at least 1, this has to at least be 2, which means this would have to at least be 3, at least 4, at least 5, at least 6. Okay, so if something like this is at least 2, then n has to at least be what? N has to at least be 2 to the power of 5. How about over here? N would have to be at least 3 to the power of 4. Here, n would have to at least be 4 cubed, 5 squared, and this one is greater than or equal to 1 to the power of 6. Let's simplify all of these real quick. So n is greater than or equal to 1, n is greater than or equal to 32, n is greater than or equal to 81, 64, 25, 6. Okay, and this is the worst case scenario. Another way you can say this is that this is the strictest inequality. So we're going to look at it. If n is greater than or equal to 81, then this is at least how much? What's the sixth root of 81? So 2 to the power of 6 is equal to 64. And 3 to the power of 6 is equal to 729. So basically, I was unsure of what the sixth root of 81 was. So I was looking at perfect sixth powers nearby. And since 81 is in between this and this, the sixth root of 81 is going to be in between 2 and 3. So that means the floor would be how much? So that means the floor of the sixth root of 81 is going to be equal to this 2. Okay, so that means this is actually at least 2, this is at least 3, this is at least 4, and so on, 5, 6, 7. And we're going to repeat what we just did here. So by a similar process, n would have to at least be 2 to the power of 6, at least be 3 to the power of 5, 4 to the power of 4, 5 to the power of 3, 6 squared, and 7. All right, simplifying, 2 to the power of 6 is 64, 243, 256, 125, 36. Okay, so this is the strictest one. So n is at least 256. Okay, so what is the sixth root? What's the floor of the sixth root of 256 going to be? So again, 256 is between this and this. So by a similar thought process, we're going to get that the floor of the sixth root of 256 is also equal to 2. Okay, so yeah, I'll just write 2 here. What's the fifth root going to look like? The floor of the fifth root of 256. Well, we know that 3 to the power of 5 is equal to 243, and 4 to the power of 5 is 1024. So these are the perfect fifth powers that are close by to 256. And 256 is in between 243 and 1024. So that means this is going to be equal to this. And then the fourth root of 256 is 4. It's the same idea here. Look for nearby perfect cubes now. So 6 cubed is 216, 7 cubed is 343. So this one's going to be equal to 6. And then the square root of 256 is 16, and then this is just 256. So this inequality chain is indeed satisfied. So that makes 256 the answer.